This video is going to be about naming compounds. We're going to start with the ionic compounds, and then we'll talk about the covalent compounds. The first thing you need to know is that an ionic compound is made of a metal and a nonmetal. The metal will always come first. These compounds are found most often, and that's just simply because there are more metals than there are nonmetals. A balanced compound is going to be based on canceling oxidation numbers. So what that means is if I begin with a metal that has a +2 charge, my nonmetal must have a -2 charge so that the overall charge is 0 or neutral. When I have a neutral oxidation number, then I have a balanced compound. Covalent compounds are made out of two nonmetals. They occur less frequently than ionic compounds simply because there's not as many nonmetals as there are metals. They're based on the prefixes given in the name rather than canceling out oxidation numbers. And this is because in covalent bonds you have the ability to have a single, a double, or a triple bond. Double and triple bonds in essence absorb the charge of the electron, so you get a balanced compound. But you can't put that on paper. So when you do the math on the paper, the charges won't necessarily cancel out. These are the prefixes that you will need to know in order to write balanced covalent compounds. Mono, di, tri, tetra, penta, hexa, and hepta. You will see those most often. Octo, nona, and deca are usually found in organic compounds. Since we are in an inorganic chemistry class, you won't see 8, 9, or 10 very often. Now that you've been introduced to the basics of ionic and covalent bonds, let's practice naming some compounds. We'll start with the covalent compounds because they're the easier of the two. Remember, you're not using charges or oxidation numbers, you're using prefixes. The first thing you need to do is to identify that you have a covalent bond. Remember, covalent bonds are two nonmetals. The nonmetals are going to be found on this side of the periodic table. So you have carbon and you have oxygen. They're both on the right side of the periodic table, and they're both in the negative oxidation number sections, so you know that you have a covalent bond. So you're just going to write carbon, and then you have oxygen, but you have two. So the prefix is carbon, di, and then to know that you have a compound, you're going to change oxygen into oxide. This IDE is what tells you that you have a compound. If you want to be fancy, you can call it monocarbon dioxide. But mono isn't really necessary because you already know that you have one. Second example, N. We're going to look over here. Nitrogen. And we have chlorine also over here. So again, we have a covalent bond. This time we have three of them. Nitrogen, tri, chlor, and the final IDE. Hydrogen. Now hydrogen is unique. It's found on the metal side, and it even has a +1 charge. But because it is a gas, it's considered a nonmetal. So you have hydrogen, but you have two, so it's dihydrogen oxide. And again, if you want to be fancy, You can put mono here. You won't be wrong. You're just being extra careful. A couple more examples. P, phosphorus. Br, bromine. But it's in a compound. Bromide. And we have 3. Phosphorus tribromide. S, sulfur. Oxygen becomes oxide. Di for 2. Monosulfur, okay, not necessary. C for carbon. Chlorine becomes chloride. And 4, tetra, carbon tetrachloride. This is exactly how you're going to need to do it for all tests, quizzes, and worksheets, and it doesn't get any more difficult than this. I'm going to move now to naming ionic compounds. Now we're going to work on some ionic compound examples. When you're naming the ionic compounds, you don't have to worry about oxidation numbers unless you're talking about elements that have multiple oxidation numbers. Remember, it's this group, and this group. When you have those in your compound, you're going to have to designate what oxidation number is actually used in this compound. Other than that, it's just a simple naming right off the periodic table. So the first thing you need to do is to identify that you have an ionic compound. That means you have a metal and a nonmetal. Remember, metals are on the left side, and they are also the ones that have the positive oxidation numbers. Metals always go first in ionic compounds. So Be here, beryllium, and S, nonmetal. Nonmetals always come second. Sulfur, and because it's in a compound, IDE. Na, sodium. This 2 is to balance the charges. It does not have to be included in the name. O, talked about that before, oxygen becomes oxide. Fe, iron. If you notice, iron is in this middle section. It has a multiple oxidation number possibility. So we're going to leave a parenthesis there for the moment. Br, bromine, becomes bromide. Now we need to fill this. This is the oxidation number that goes with iron. Iron's oxidation number is going to be found with bromine because this is the number that was used to balance the charge. 2, Roman numeral 2, iron 2 bromide. Our next example, Ag. Ag is found here in that middle multiple oxidation number section. Ag is silver. Leave that space because we're going to have to fill that in a minute. O, oxide. If you look right there, there's no number. That number is an implied 1. That number goes in that spot. Silver 1 oxide. Al, aluminum, found here, I over here, iodide. If you notice, although it's in that section that I said has possibilities of multiple oxidation number, aluminum does not. When we get deeper into what are the rules for multiple oxidation numbers, I will explain why. Last one, Cu, searching, 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 found right here, copper, again in this middle section, so we're going to need an oxidation number. F over here, searching, searching, fluorine, which becomes fluoride, and again, there's your number. That's what we needed for balancing. Copper 3 fluoride. Doesn't get any more difficult than this. The hardest part is remembering to take the time to search to see if you're going to need this Roman numeral or not.